Okay, welcome back. Today we are going to talk about the next two sections, 7.3, 7.4, which have to do with slope fields. So we are going to estimate solutions to a differential equation, where before we were checking to see, they were given to us and we were asked to check to see if they were solutions. Now we're going to try to estimate solutions. Later, we're going to learn how to solve differential equations, but sometimes that can be quite difficult. Sometimes it's impossible. So we're going to take a graphical approach first, and this is called creating slope fields, which shows the general shape of the solutions to the differential equation. So at first we were given them, and we were saying, okay, check to see if these are solutions. Now they're saying, find a solution. And this is the graphical approach. So this is our differential equation here. We've got our first derivative in terms of x and y. Okay, we're going to sketch a slope field of this differential equation. Now, again, this first derivative represents the slope of the tangent line to the curve at any point. So what we're going to do is we're just going to draw in mini tangents. We're going to plug in some coordinates into this first derivative, and it's going to give us the slope of the tangent line. So we're going to create little mini tangents. So it's easiest to start where the first derivative is equal to 0. That's the easiest place to start. Okay, so where is our first derivative going to be equal to 0? Our first derivative is going to be equal to 0 when x is equal to 0. So what I'm going to do is I'm just going to put some mini tangent lines at x equals 0. So at x equals 0, if I plug in 0, 2, if I plug in 0, 1, 0, 0, if I plug in any of these coordinates into here, I'll get 0 divided by something. So the slope at x equals 0, the slope at that point, I'm going to just draw a little mini tangent line at that point. Okay. Now, where's this going to be undefined? Where is our first derivative undefined? Well, that's any place where y is equal to 0. Okay. So our first derivative is undefined when y is equal to 0. So this right here is where y is equal to 0. So the first derivative is not always undefined on all of the solutions, but in this one it is because we have a y in the denominator. Okay, or it could be here as well. Okay, little mini tangents. All right, and then you can just pick, any x value. On the A/B test, they may have you draw 6 mini tangent lines. On the BC test, I have not seen them actually have you draw these on a free response. But we're going to go through and do this anyway because you do have to know how to come up with solutions on the BC test. So let's just go to this point right here. This point right here is 1, 1. So if I plug in 1, 1, I get a slope of -1/2. The first derivative is equal to -1/2. So if the graph were to go through this point, what does a -1/2 slope look like? Well, -1 slope would be at a 45. So again, we're just guesstimating what a -1/2 slope would look like if the graph were to go through that point. Okay, we can do this point here. If we plug in 1, -1, that gives us a -1/2 slope. If you plug in this point right here, that would be -1, -1. You're going to get a -1/2 slope. So you can go through and you can plug in every single one of these points in for x and y and figure out what the slope of the tangent line would be. Okay, that might take you a little while. So I'll just go ahead and give you a couple more. this right here is going to be, the tangent line would be here, because if we plugged in 1, 2, that's going to be -1/4. So it's going to be a little bit flatter than a -1/2 or a +1/2. Okay, so a little bit flatter. And again, these are just guesstimations. Okay, so and we can even do some more if you want, but I think that's plenty. Okay, it says sketch a slope field of the differential equation on the coordinate plane, plug in x and y into the differential equations, and then draw a short line segment by estimating the appropriate slopes, which is what we just did. Okay, now most of the time they're drawn in for you if it was a free response question. Sometimes, like I said, on the A/B test, they'll ask you to put in 6 or 12 or something like that. Okay? So that's part A. Part B says sketch one possible solution curve to the differential equation that passes through the point 0, 1. So it's giving us a point on the actual graph, and these are possible tangent lines to that graph. Okay, so I'm going to go ahead and I'm going to sketch in, I'm going to go through 0, 1. So where is 0, 1? 0, 1 is right here. So I know that my solution is going to go through that point. Well, if my solution is going to go through that point, okay, it's going to be tangent to these. So I know that the solution curve is going to start something like this. Because I know it goes through this point, and I know that these are little tangents to the graph. Okay, so I'm just going to go ahead and see what I can do to complete this. If I go with this curve, now again, here's some more possible tangents here. So I know that the curve, this is a possible solution to the differential equation. Okay, and again, that's kind of looks like an ellipse, right? So the equation of this graph would be a solution to this. So that is sketching one possible solution. It goes through this point and satisfies this differential equation. Okay, so if I were, notice here, this is where you're undefined here. Okay, so that is a possible solution curve. All right, so let's take a look at some multiple choice. So this is the differential equation. It says shown to the right is a slope field. So here's your slope field. These are all little mini tangents that are drawn for you. Which of the following differential equations satisfies this? So if I were to take any of these, notice this right here. This looks like y. That looks like y equals x plus 1. That's what it looks like. But I'd like to start with these horizontal lines right here. See these little mini tangent lines? That means that the first derivative, I'd like to start here. That means that your first derivative is going to be equal to 0 at all of those coordinates. So what would that coordinate be right there? Okay, that coordinate right there looks like it's 1, 1. That looks like it's 2, 2. That looks like it's 3, 3. So basically what it's saying is that x, if our x is equal to 1 and our y is equal to 1, our first derivative is equal to 0. So which one of these would satisfy that? 1 plus 1? No. 1 minus 1? This looks like it might satisfy that, but we have to make sure they're all satisfied. So let's keep going. How about this? The opposite of 1 plus 1? That satisfies that. Or 2, 2. And then this one, 1, 1 satisfies it, but 2, 2 does not. So we can cross off this one, we can cross off this one. Okay? So now we have we're down to 2 choices. So let's go to something else that we recognize. Okay? What else do we recognize? Let's look at another point. Let's look at, say, 0, 1. At 0, 1, when we plug 0, 1 into the derivative, it should give us this slope right here. That looks like about a slope of 1. So let's just go ahead and let's plug in 0, 1. Okay? Let's plug in 0, 1 into this one. If I plug in 0, 1, I get a slope of, first derivative, I get a slope of -1. Does this look like a slope of -1? Nope. How about if I plug in 0, 1 here? I get a slope of 1. Does this look like a slope of 1? Yes. And you can pick another point if you want to. You can go, I don't know, this one right here looks like 1, 2. So when I plug in x equals 1, y equals 2, which one of these gives me that tangent line slope of 1? And so C, it looks like C is the answer. Okay? So let me kind of review what I just did. Okay? So let's go back up to here. What did I do to sketch a possible curve? Okay? What we did was we sketched a graph through the given point. Okay? And we're also, so the given point, and using these short line segments. Well, what are those short line segments? Those short line segments are your mini tangents, possible tangents to the curve. Okay. We use those to guide us. Okay. So in the first one, I actually had to draw in the mini tangents. On this one, all the mini tangents are drawn for us. We just have to find out which one of these differential equations will give us these mini tangents. And again, there's so many tangents. Where do you start? So start with the easy slope. I like to start with 0. Hopefully there's a slope of 0 somewhere. Okay, so on this graph, the slope, it looks like the points where the tangent line is equal to 0 are 1, 1, 2, 2, 3, 3, etc. So I can eliminate these. Again, I need to plug in an x and a y, and I'm going to get a first derivative equal to 0. So that gives me, that narrows it down from 4 choices down to 2 choices. And then I can pick another slope. You can pick anything you want on here. But I'm looking at these mini tangents. And again, these mini tangents look like the slope is approximately equal to 1. So this is going to give me, when I plug in each one of these points, I'm going to get a first derivative equal to 1, because the slope of the tangent line is equal to the first derivative. Okay. So right now, this narrows it down to B, or C. But now when I go to get another here, if I go to this point or this point or this point, again, you're just estimating this point right here, let's just say that is 0, 1. Looks like it's 0, 1. So looking at the point 0, 1, I need my dy dx to equal 1. So of the two equations that are left, which one gives you a slope of 1? And the answer is C. Because the opposite of 0 plus 1 is equal to 1. Okay? So you have to understand what these little mini tangents are. All right, let's take a look at the next one. There's a bunch of mini tangents here, which looks kind of crazy, doesn't it? So what are we going to do here? It says the graph to the right shows a slope field of a function f of x. And again, we're trying to find what f of x is. Okay, that's our goal, is to try to find the solution curve, something that satisfies our derivative. Let's see what else it says. It says if the initial condition is 0, 6. So that means 0, 6 is actually on our solution curve. So where is that at? 0, 6 is right here. And you can see that little mini tangent right here. That point right there is on the curve. There's our tangent line right there. Okay. It says, what is the range of the solution curve for the function for x is greater than or equal to 0? Okay. Well, if we know that it goes through, we know that it starts at that point. That's the only thing that we know. And these are little mini tangents. And look at this right here. This looks like a horizontal asymptote at y equals 4. So based on everything that's given, the only thing that we know is that this point is on the graph, and it's going to be tangent to some of these, one of these in here, and it's going to approach this. So that's what a possible solution curve would look like. So it says, what is the range of the solution curve? Well, what is the range of this? And if you remember, range is from bottom to top. So our range of our solution curve, it's approaching 4, doesn't get to 4, and the only thing we really know is that it goes up to 6. Anything other than that, we would be making an assumption. Okay? Let's just keep looking at some examples. What is a general solution to the differential equation that generates the slope field here? So now we're given a slope field here. Okay. They don't really give us a coordinate, but let's look at these equations over here. Let's look at the answers to kind of guide us. It looks like we have y equals sine or cosine or negative sine or cosine graphs. So let's look at our mini tangents here. You see we've got a mini tangent to the curve right here. There's a little mini tangent there. Okay. There's little mini tangent here and mini tangent here. Okay. So if you kind of look, what graph is that? You kind of sketch something in, that looks like I can draw a curve, tangent. What graph is that? That's the sine graph. Well, they didn't give us a coordinate that the actual graph went through, so we don't know if we should be sketching here, or we should be sketching up here, or down here. We don't really know. So here's the sine graph, and it could be plus any constant. So we can translate this up and down, and still, you're not going to be tangent to all of these. You're just going to be tangent to some of them. So it looks like E would be the answer for that one. Okay, so we found a solution by using slope fields. And if you recall back in section 7.1, or actually 7.2, they gave us the solution to verify. Okay, we're going to eventually get to the trying to find the solution ourselves. This is the graphical way of trying to find the solution. Okay. All right, let's look at example number 5, last example. Here's our differential equation. Describe all points in the xy plane for which the slopes are positive. Which the slopes are positive. So in order for our slopes to be positive, what must be true? Well, if x squared times y minus 1 needs to be positive, what must be true? Well, x squared is always positive. So that means that y minus 1 has to be positive. Because if this is always positive, and you want all your slopes to be positive, then this also has to be positive, which means what? That y has to be greater than 1. Okay? So what else must have to be true? Well, neither one of these can be 0, right? Because we want our slopes to be positive, and 0 is neither positive or negative. So x squared, oops, x squared is not only always positive, but it cannot equal 0, because at any time x squared is equal to 0, 0 times anything is going to give you 0. And again, we want all of our slopes to be positive. So what must be true? Okay, so this is the first thing that must be true. Y must be greater than 1, not equal to, because that would cause it to be 0. And the second thing that must be true is x squared cannot equal 0. So if those conditions were satisfied, you would be giving me a slope field where all the slopes are positive. Okay? So again, what are these differential equations? Just think of this. What is dy dx? Well, that's a derivative, right? Dy dx. That is called a differential equation. That's a first order differential equation, because that's the first derivative. So dy dx is a first order differential equation. Okay, so think of it as a formula to produce slopes, or tangent lines, slopes, little mini tangents at any point. Okay? So that's how the slope fields are created. You're plugging in points and you're trying to find what the possible, the slope of the tangent line would be at those points if the graph were to go through it. Okay. So that's 7.3 and 7.4 dealing with slope fields.